Okay, in this video we're going to look at graphing functions and looking at functions on in tables of values and working with functions in different ways. Okay, so it's kind of an extension of the definition of a function and working with functions in an equation. Okay, so in number 7, it says graph each function, make a table of values if necessary, and you may use your calculator as an aid. Okay, so part A, we have f of x equals 3/4 x plus 7. Well, remember that f of x was just a function notation, or a fancy way of writing y equals. Okay, so that's an equation that you should be able to graph by now in this class. It's a linear function, okay, or linear equation, with a y-intercept at 0, 7, and a slope of 3/4. Okay, remember that means you count up 3 to the right 4. Or go the opposite directions, down 3, left 4. We can start at the point 0, 7, okay, because our b value is positive 7. Okay, so we can graph that line. And I'll show it here in the answer key in a second. Part B, we have g of x. Remember, that's a fancy way of saying y equals x squared plus 2x minus 4. Now I have a table of values here shown. Okay, but if you use your calculator, okay, if you go to your table and put in x squared, okay, so x squared and then plus 2x minus 4. Okay, press enter. And then mine is just starting at -2, but so you can type that in if you want or put in 0. Do a step of 1 with the auto and then go to your table. And when you have a grid given to you like you do over here, okay, you want to plot all the points that fit on the grid. Just using a scale of 1 in this case. So as you scroll to the negative numbers, notice that once we get to -5, we're up at 11. -6 gives you 20, and so on. So those values won't fit, so you can leave them out of the table. Okay, so -4, 4 was the first one I put in the table, and then -3, -1, and so on. Okay, and as you get larger for x, okay, notice that once you get to 3, you get to 11, which will be off the table. And I just included it at the end, just to put it there. Okay, so that'll tell you what values you want to be able to put in a table of values that you can fit on the grid. Okay, so graph the line, and then graph the quadratic function, okay, by plotting these points. And when you do that, you'll end up with a graph that looks like this. Okay, the green one is the line, and the blue one is the part B, quadratic function, g of x. Okay, part C, it says using the graph, find the value or values of x for which f of x equals g of x. Okay, so that's basically saying, where does y equal y? Well, that looks kind of weird to say, but it's saying where do the y values on the f function, which is the line, equal the y values on the g function, which is the u shape. Well, the two functions are equal to each other when they intersect. They intersect at those 2 points. So what x values do they intersect at? Well, this x value here is -1, 2, 3, 4. Okay, so x equals -4. And then this one over here, you have to estimate a little bit. It looks like, here's 2. That'd be here on the graph. And then it looks like maybe about halfway, like 2.5 or 2.6, somewhere in there. Okay, so I'd say approximately 2.6. So those are the two x values where the y values are equal to each other on each graph. Okay, moving on to question number 8. Determine whether the following represents a function and explain your reasoning. Okay, in the past, you've had questions where it asks you, does the relationship represent a linear equation? Well, remember, for linear, that means that you have to have the same pattern between the y and the x. Pattern meaning the slope has to be constant. Okay, so for example, if you add 2 to y and add 1 to the x, that pattern is y going up by 2 every time x goes up by 1. Okay, so as long as that happens, that same pattern holds true, then we have a linear relationship. For a function, All that's asking you is, does each x have at most one y? So if x is -3, do we only get one y value? Yep, we get a y value of 5. If x is -1, we only get one answer for y. Okay, so essentially when you're looking at a table of values and trying to determine whether they have a function or not, okay, basically what you're looking for, like the one thing to really tip you off, make sure that the x value does not repeat itself. Because if the x value shows up at more than one place, like just suppose -3 showed up here instead of 5, okay, then you have an x value that may be going to different y values. Okay, so make sure the x value does not repeat, then you'll have a function. Okay, so the answer there, yes, this is a function because each x corresponds to at most one y. Okay, the next one, part B, we have a bunch of ordered pairs, which is really all that a table of values is. It's just shown in a different way. Okay, so as you go through the ordered pairs here, it's a little more confusing to look at, okay, just the way it's set up. But notice how we have an x value of 4 show up twice, and that value of 4 goes to 7 and +2 for the y values. So that means we don't have a function because x equals 4 corresponds to 7 and 2, okay, more than one y value. Okay, on the next page, okay, now we're going to look at representing a function in 3 different ways, basically looking at equations, graphs, and tables and how they're related to each other. And we note that any function passes the vertical line test. And again, what that means, if you take a straight edge like a ruler, and if you were to treat the edge of the ruler as a vertical line, and as you move straight across, so as x gets larger, do you ever hit the graph at more than one place? Okay, so here, like when x is -2, you only hit the graph at one place. As you scroll across, x equals 0, you only hit one place. X equals 2, you only hit one place. X equals 4, you only hit one place up here. So that vertical line test tells you we have a function. Okay, so that answers part A. We have a function because each x has at most one y. Part B, write the equation of the graph. If it's a function, call it f of x, and write the equation in function notation. Well, here we have a line, like y equals mx plus b. The m value is a slope, so as we count the slope, find any two nice points on there. If I start right here, notice if I go up 2 to the right 1, up 2, right 1, I stay on the graph. So that tells you the slope is 2. And the y-intercept, the b value, is at -1. Okay, so it's a pretty easy one. F of x instead of y equals, f of x equals 2x minus 1. Okay, moving along, if you look at this table of values, so when x is -3, what is f of x? Okay, so what is the y value? Remember, the f of x is just a fancy way of saying the y value. So when x is -3, we can actually go to our function and do 2 times -3 is -6, subtract 1 is -7. Or we can look at our graph up here. When x is -3, the y value is right here at -7. Okay, if x is -1, well, we can do 2 times -1, which is -2 minus 1, which is -3. Or we can look at our graph. When x is -1, the y value is down here at -3. Okay, so we can go through and fill that table in. Okay, so take a minute and do that. I'm just going to show the answers, but you can pause the video if you need to. Okay, and there is our table. Okay, part D, evaluate each of the following. So f of -3. Again, you need to remember the function notation was f of x. Okay, that's our function f of x. So what that's telling us, oops, let me write this first. Remember, f of x is your function. So f of -3 means that the x value is -3. So when x is -3, what is the y value? -7. And the next one, f of 0, again means that the x value is 0. So when x is 0, what is y? Negative 1. Okay, so equals negative 1. And then the last one, f of 3, means that when x is 3, so when the x value is 3, what is the y value? 5. Okay, in part E, now we're going to find x given f of x equals negative 3. Well, remember, this is saying that y equals negative 3. They're not telling us that the x value is negative 3 because the negative 3 is not in parentheses next to the f. Okay, so if the y value is negative 3, what is the x value? Well, y equals negative 3 right here. X is negative 1. Okay, so what you cannot do is you cannot say equals negative 1 here. You can't just do this. Equals negative 1. Well, first of all, does negative 3 equal negative 1? No. And the second thing is, they're giving you the y value here, and it is negative 3. So you have to write, what is the x value? Notice how it was in parentheses? So you have to say x equals negative 1. You can't just say equals. Okay, we can't do this. You're going to miss points every time if you do. Okay, compared to up in the ones here, where we're given the x value and we have to find y. Okay, the reason we could do that is because they were saying, if x is negative 3, the y value equals negative 7. Okay, which is different than when you're given the y value of negative 3, the x value is negative 1, and this is how you write it. You have to actually say x equals negative 1. You cannot write it as equals negative 1 like this. Okay, the next one, f of x equals 1. So where does the y value equal 1? Well, we look in the table, the y value, or the y column, and we don't see a 1. So we can look at our equation or our graph. So when y equals 1, what is the x value? Okay, so if y equals 1, what x value gave you a y value of 1? So there's two things you can do looking at the table. A y value of 1 is right here. Well, what x value gave you that? An x value of positive 1. So we know that x equals positive 1. If you use your equation, okay, what you can do is you can solve the equation 1 equals 2x minus 1. And then, if you add 1 to each side, you'd have 2 equals 2x, so x equals 1. Okay, for the next one, f of x equals 3. Well, here in the table, we see the y value is 3, right here, when x equals 2. Okay, so we can just say x equals 2 for that one. Or you can solve the equation 3 equals 2x minus 1. So there you would add 1 to get 4. So 4 equals 2x. Divide by 2, you get x equals 2. And then f of x equals negative 5. Well, again, we don't see it in the table here. The y value of negative 5, we skip over it. So again, you can use your equation or your graph. If you use the graph, y equals negative 5 is right here. Well, the x value that happens at is negative 2. So you know that x equals negative 2. Or you could solve the equation negative 5 equals 2x minus 1. If you add 1 to each side, you'd have negative 4 there equals 2x. So x would equal negative 2. Okay, moving along on the next page. Okay, now we're going to look at graphs. I was covering up the answers here. Okay, so now if you're given a graph, we don't have an equation for our function, and we don't have a table of values given to us. Okay, but we just have a graph. So this is number 10. We have a graph of g of x. We want to find g of negative 2. So remember, that means if the x value is negative 2, what is y? Well, x equals negative 2 is right here. What is the y value? 2. Okay, so x equals, when x equals negative 2, we get a y value of 2. G of 0, means when x equals 0, what is y? Well, an x value of 0 is right here. We hit the graph down here at -4. So g of 0 equals -4. Okay, g of 3, when you put 3 into your function for the x value, we get a y value down here. We have to estimate where that one is. Okay, maybe about -5.5. Okay, so about -5.5. Okay, the next one says g of x equals 2. So now, instead of giving the x value, we're given the y value. So where does the y value equal 2? Well, the y value is 2 right here. And where does that happen? On the graph right here and all the way over here. So we get two answers at x equals -2 and x equals +6. Okay, so -2 and +6. Okay, and if you take a second and finish the last two, okay, g of x equals -6 and g of x equals 0. Okay, I'm going to show the answers, but again, pause the video and just take a few seconds and try them. Okay, but the answers, okay, here. Okay, g of x equals 0. Okay, that's really finding the x-intercepts because it's saying that y equals 0. And remember, to find an x-intercept, you set the y value equal to 0. Okay, the next graph, okay, is a similar question to the first one, except it's just a crazier looking graph. Okay, so we just have this weird looking function here. Okay, but the concept is still the same. Okay, so take a minute and go through and see if you can find these. Okay, f of 0, remember that means that when the x value is 0, what's y? Okay, and then try those, and I'll put the answers up. Okay, so pause the video and see what you come up with. Okay, this one's a little bit more difficult than the last one. Okay, but try them. Okay, and here's the answers for those. Okay, the trickiest one here is part F. Find x if f of x equals 2. Remember, that's saying y equals 2. Well, the y value is 2 right here. So if you go straight across, you hit the graph here, 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 and also way over here. So there's actually 4 answers for that one. At -6, okay, right here, at -6. At -4, x equals -2. And then over at about 5.5, okay, right around there. Okay, so that's looking at functions 3 different ways, basically using an equation, using a table, and using a graph.